Let p be the least prime number for which there exists an integer n such that n to the power of 4 plus 1 is divisible by p squared. Find the least positive integer m such that m to the power of 4 plus 1 is divisible by p squared. Or that means they want you to find the least integer m. Least integer m. Okay, in this case, we can take note that p cannot be 2. Because why? Because we notice that n plus 4 plus 1 is not divisible. It's not divisible by 4. Because your p is 2, therefore p squared will be just equal to 4, right? For any integer n. Obviously, it must be positive integer lah. All right. Okay. Then suppose n to the power of 4 plus 1 congruence to 0 modulo p. That means in this case, n to the power of 4 plus 1 is divisible by p. This implies that n to the power of 4 congruence to negative 1 modulo p. Modulo p. Therefore, n to the power of 8, you square both sides, will be congruent to 1 modulo p. That means n is of order 8. That means in this case, n has order 8. Order 8. Therefore, what does it mean? This implies that 8 divides p minus 1 because p is a prime. Right? Therefore, the least p in this case would be just equal to 17. Alright, least p would be just equal to 17. Alright, and what does it mean? That means in this case, your m, this smallest m, this smallest integer m, such that m to the power of 4 plus 1 is divisible by p squared. This n must be 17, must be equal to 17 k plus r. Right, and obviously r is a remainder, right, which is r must be greater than 0, greater than or equal to 0, and less than or equal to 16, basically. All right. Therefore, now we can use binomial theorem. N to the power of 4 plus 1 is equal to 17k plus r raised to the power of 4, and then plus 1. All right. And in this case, you just expand 17k to the power of 4. And then this is 4, and then 17k to the power of 3, and then this is r, and then this would be 6 17k squared, and then this is r squared, and then this would be plus 4 17k, and then this is r to the power of 3, and then the last one is r to the power of 4, and then plus 1. All right. Okay, in this case, can you see that there is a possibility that you take out 17 squared, all right? And you will get to 17 squared k to the power of 4, and then plus 4. Okay, this would be 17, and then this is r, right? Okay, sorry, there's a k cube. Don't forget the k cube. Therefore, this is k cube, and then this is r, and then plus 6. And then k squared, and then r squared. All right, and then can you see that you close the bracket? Then this part here is 4 times 17k, and then r cubed plus r4, and then plus 1. All right, and can you see that this what does it mean? That means this is divisible by 17, right? Divisible by 17, right? And can you see that? This m to the power of 4 plus 1 is an integer. When you divide by 17 squared, right? When you divide by 17 squared, can you see that it's an integer, right? This is an integer. That means this imply what? Okay, that means m to the power of 4 plus 1 is divisible by 17 squared if and only if what? Okay, sorry, this part here, ignore. That means m squared, m to the power of 4 plus 1 is divisible by 17 squared, provided this particular piece is also divisible by 17 squared. All right? Therefore, this is 17 squared, sorry. 17 squared. Okay, now, therefore, if and only if 417 k cubed plus r to the power 1 plus 1 is divisible by 17 squared. All right? And in this case, I can do a splitting. That means 417 k cubed plus r to the power 4 plus 1. You divide by 17, 17 square. This is 17 squared. That means what they are trying to say is that this fraction is actually an integer, right? Therefore, what you get is I can push the 17 on top. I will get 4k cubed, and then this is actually r to the power 4 plus 1 divided by 17 divided by 17. All right? That means I split the 17 into numerator and denominator, and this is actually equal to an integer, right? Therefore, what does it mean? That means this part here, it has to be an integer, right? That means r to the power 4 plus 1 is congruent to 0 modulo 17, right? And in this case, you can see for yourself that your r can be what? Your r can be 2, can be 8, can be 9, and then can be 15. Or can be 15. Okay? And with that, right, you write down the three value. That means r, k. All right? And then also m. And also m. You write down these three value. Okay? You realize that you will get this. That means in this case, when r equal to 2, the value of k is 9. And then the value of m will be 155. All right? And then followed by when r is 8, the k value is 6, and the m value is 110. You can check. And then after that, when the r value is 9, the k value will be 10, and then the m value is 179. And then finally, when your r is 15, then your k value is 7, and this will be 134. Therefore, if you look at the m value, 155, 110, 179, and 134, the least prime. Can you see that in this case, can you see that the least possible prime we know that is 17, right? We know that is 17 here, right? And then least possible integer, least positive integer m, and that is such that m to the power of 4 plus 1 is divisible by 17 squared is just equal to 110. Take note, this least possible integer is the case whereby m to the power of 4 plus 1 is divisible by 17 squared. All right, and this number, the number m is actually 110. Yeah, with that I stop here.